All right, let's get started. This talk is on building SpiceDB, which is a gRPC native database. Just to clear the air before starting the talk, this database is not for storing protobufs in it. So it's not for specifically storing protobufs, but it is for a database whose primary querying interface is not something like SQL, but actually gRPC. A bit of background on me. I'm one of the creators of SpiceDB and co-founders of a company called authzed. Previously, I worked at Red Hat through the CoreOS acquisition. So I've been in kind of like the cloud native ecosystem since the beginning. I'm actually an OCI maintainer, so that's the standards body behind containers. I've created a bunch of different projects in the CNCF as well. The slides are uploaded online, so if you want to contact me, you can reach out to me on any of these places. My email is probably the best place. I'm going to go pretty quick just because I have a lot of content. Does anyone know what this is? Do they remember this? We've got some Googlers here. You should know this. Exactly, it is. It's Google+, correct. So Google+ is the old social network that Google built, I think around 2011. Yep. And it had this one particular feature that's really interesting called circles. And what circles were the ability for you, unlike another social network kind of like LinkedIn or Facebook, where you would just directly connect to another user or friend another user, you could actually put users into buckets. And those different buckets could have different data shared with them. So you could post and say only one particular group gets access, or the intersection of these two groups, or the union of these two groups. Basically gave you set logic around sharing. And that was actually driven by an internal system at Google called Zanzibar. And SpiceDB is actually the open source inspiration created by Zanzibar. So what we do is we're an open source database written in Go. It's Apache 2.0 licensed, and we are purpose-built for storing and querying authorization data. So it's not a general purpose database. This is just a database specifically for querying whether or not a particular user or entity has access to perform an action on another entity. You might be wondering why you would need something like this. What it really empowers is kind of two things. It gives you the ability to kind of centralize authorization across your business or a product portfolio. So if you have something like Gmail and Google Drive at Google, you can implement interesting behavior, like if you send an email to someone that has a Google Doc link in it, Gmail can actually pop up a warning and say, hey, you didn't share this with this person. That's because it could query the central authorization service to ask whether or not the user that you're emailing has access to that doc. So there's no shared code between Gmail and Google Docs. It's just doing this permissions check at the authorization layer. So it gives you kind of that functionality, but it also kind of gives you this social functionality that you can actually have a team dedicated and centrally managing authorization across your business. So a lot of companies right now, they have ad hoc implementations of authorization across all their different applications. And that leads to a lot of different inconsistencies across the board. It's really hard to audit. Maybe you have pulled some of that stuff out into a library, but the second you have different programming languages in your stack, okay, now you can't really share a bunch of that logic. So what we have here is basically the network layer separating that and having a dedicated service. And that means you can build a team around it. That team can help onboard other customers within your company to understand basically the best practices and how to keep everything secure and scalable. So example of some queries that you can do in SpiceDB are asking whether a subject can take a particular action on a resource. That's just a permissions check. That should be super familiar to people. But where SpiceDB really shines, and the advantage it gets by actually owning the data in its own database, is that you can do kind of different style of queries to this data, like discovering all the subjects that can take a particular action on a resource, or discovering all the resources that a particular user can take an action on. Most other systems can only kind of do this first check, but we can actually kind of help you discover and understand the relationships between a lot of this data. So if you do have an outage or a security flaw, you can actually go back after the fact and query it and really understand what that data looked like at that point in time. All right, enough about SpiceDB. We're a database, right? Why didn't we pick SQL? Like, it's the obvious question. You're building a database. It's time to whip out the SQL. But It turns out we're not really a general purpose database. We have very specific queries we're trying to target and make those as fast as possible. This gives us an interesting dynamic where we actually don't really need to do dynamic query planning quite as much as a general purpose database does. In a general purpose database, you have to kind of parse the SQL and then build a structure for how you're going to execute the plan to fetch that data. We don't have to do that because we actually kind of hard code a lot of that logic into the schema itself. So we didn't really need the general purposeness of SQL. The other thing is SQL just has a lot of baggage. If you look at a typical kind of SQL wire protocol, I'm honestly just talking about Postgres in this scenario, but MySQL is not great either. Basically, they're stateful on the connection. You're not going to be able to multiplex multiple requests over a single connection. It's pretty inefficient. And then if you're trying to really get bang for your buck, you're probably going to want to try to reuse some of the clients in the ecosystem so that you don't have to implement clients in every language. And a lot of those have logic built into them, trying to deal with kind of inadequacies in Postgres that might not exist in your database. For example, how they manage memory for connections on the server side. And if SpiceDB is written in such a way that it doesn't have that same constraint, then it's kind of just lost performance. So we arrived at gRPC. And we kind of landed on it for a couple of different reasons. The big one is the IDL. So having an IDL format to define your APIs ahead of time and kind of code review and study that and use tools like Buff to lint it and just understand and generate docs. Super, super useful. The real thing is the maturity and the multi-language aspect of gRPC. So the fact that we knew we could generate clients in all the different languages our customers would possibly be using. We know that out there, everyone's going to be using every single language. So the ability for us to support all those languages as easy as kind of just running a Proto-C generator was really important. The other thing is just gRPC's been around. We're celebrating the 10th anniversary, right? Not many other formats like this have been around that long, and they're not as stable. Like realistically, there are little hiccups between Proto 2 and Proto 3, but not really in the same way that you would find even at like any of the other formats that exist right now. If you went out and looked at like Captain Proto or flat buffers, they're making similar changes that are kind of on a scale breaking more than what you'd find between 2 and 3. And then we also had built a lot of stuff in Go before, and we knew that the libraries for building out gRPC services in Go were fairly mature. The other thing too is that we knew that we could get pretty reasonable performance out of it. I talk about CFFI and kind of native implementations in a bunch of different languages. We just knew the performance picking up the clients would be fairly good. So this is kind of the overall architecture of SpiceDB. The green lines are the ones where it's actually gRPC flowing into the system. So if you look on the left-hand side, you'll see that we have kind of the customers and like the applications consuming the database coming in through the front door using gRPC. We also use the REST gateway, so you can use HTTP and JSON, although we really don't recommend it. But the REST gateway basically just immediately turns around and converts the JSON into gRPC and goes right back through the front door. Then we kind of have the second use case, which is clustering SpiceDB. So SpiceDB will self-cluster when you deploy it, and it will basically take requests from the users and break them down into smaller requests that then get sharded across a cluster. So there is intra-cluster networking as well, and that is all kind of powered by gRPC. And then fundamentally, I also just wanted to call out, you can see this little schema box that also is green. We're just reusing the fact that we have the protobuf marshallers in a couple places, like how we store things in the database and how we store things in a cache. It's just convenient once you have this marshal and unmarshal functionality. So I'm going to start with the external-facing gRPC. Basically, the number one use case here is user experience. It's the thing that matters the most because this is what the journey of our customers and users, it's what they have to integrate with SpiceDB. So really the priority here was having really nice API documentation and using the IDL. That really, really helps with this because we can generate documentation off of our API definitions. And we even use this other project called Product Gen Validate. And what that does is it actually lets us define even valid strings or valid byte sequences that go into the different fields in the protobufs. And that also gets propagated then into your documentation. So you're not constantly trying to like keep synchronized your docs by hand with the actual API definitions and the behavior of your software. That's a huge deal, especially when you're dealing with multiple languages. The other thing that helps with multiple languages is the ability to kind of cut a single release, cut a version of that API definition, and then have CI and CD automation cut releases then of every programming language you support. That's really, really powerful, and the ability to automate that just is a game changer in terms of your ability to support customers in different environments. Then finally, I just wanted to add a little bit more onto the gRPC gateway. It's kind of a mixed bag. It's not the best UX from a Rust perspective. I'm sure if you hand wrote something and really paid attention, you could make a nicer HTTP API. But just like I was kind of describing with the API documentation perspective, you get a lot of bang for your buck. Like you're just kind of defining this one IDL, and then you can actually generate the REST API, and you can generate open API documentation off of that too. So you get not only documentation for your gRPC API, you also get documentation for your REST APIs, all automated based off of that one definition. Before I move on to the intra-cluster, I just kind of wanted to take an aside to talk about networking in the hot path, because authorization is super, super critical to your applications. Before your requests to your APIs talk to their database, they first need to check whether or not the action you're trying to take is allowed. So authorization is critical. If your authorization system goes down, you're not going to actually do any work anymore because you can't guarantee that people trying to do things are allowed to do things. This means we care a lot about different connection logic. So connections need to already be established. If you have to do a synchronous handshake to establish a connection, you will blow your SLA. You can't do that. You can't even do that once. So you need a connection pooling. It all has to be there. Ideally, you're multiplexing your requests across a single connection. gRPC enables that with a feature called streams. And then you just need fast serialization and deserialization on the server. And not all platforms have really fast JSON libraries if you're comparing yourself to REST. And they're tricky to write. So protobuf is definitely way more straightforward for that. Cool. So onto the intra-cluster facing gRPC use case. Here, we really care a lot about efficiency. So whereas coming through the front door, we care about user experience. When you're kind of intra-connected across your own service, you control both the client and the server, which means you can make a lot of assumptions in the name of performance and efficiency. So you can do things like guarantee backwards compatibility, just like because that's how you wrote it. You can assume configuration options on both sides, the client and the server. And one of the things that is the biggest deal here is it lets you use your own kind of custom compression schemes. So we actually use this library called Compress, and it has a experimental variation of Snappy, which is Intel's compression, which is super, super efficient. It's better than LZ4, which is probably the most common best-in-class compression you can use for protobuf. So that's really nice. We don't have to have any of our clients install weird codecs or anything. This is all just built in because it's on the server side and the client side internal to SpiceDB. The other big win here is you can't really write performance system without observability. So by adopting gRPC, we got logging, tracing, Prometheus metrics, all that middleware came for free. So we didn't have to build any of that ourselves. But one of the things we did have to build ourselves was consistent hashing for load balancing across the different SpiceDB nodes in the cluster and assigning them work effectively. So we actually got a bunch of requests to pull that out of SpiceDB, and that's actually available as a standalone library that you can use to implement your own load balancing in gRPC and Go now. We actually tried to contribute that upstream at request, and because we didn't have a reference implementation in every language, it wasn't worth the burden of like maintaining it upstream. So the Go one will live here. Maybe one day we'll get it in every language, and then that can be an upstream feature. And then basically the crux, which is great if you were here for the talk right before this, is avoiding allocations is the #1 way you get the best performance in a garbage collected language like Go. So to do that, we basically use a library called vt-protobuf. What this does is it avoids reflection in the Go programming language, which is how kind of the built-in Google-provided protobuf marshaller and unmarshaller function. So you can actually take a look at the IDL and take a pretty good guess at what the size the messages will be ahead of time, and then you can statically kind of figure out what you need to allocate and then generate code for that rather than doing it at runtime with reflection. So that's what vt-protobuf does, and if it was not for the Planet Scale folks, we would have had to implement this ourselves. It makes things way, way faster. So check this out if you're writing stuff in Go. Then the other thing we kind of learned was that we avoid nested types. So trying to keep the types as flat as possible, make the memory allocations way more simple. So you don't have to have a separate heap allocation for a nested object inside of another object. And then I was going to say that I wish there was more pooling in gRPC, but I'll talk about that more later. And then folks that saw the talk right before this, you probably got spoilers on that one. This is about the time in the talk where someone always asks me, why didn't you write this in Rust if you care about performance? And the reality actually is, if you look up gRPC bench, that's an open kind of benchmark that somebody runs on a regular interval. If you look at the latest one, Go using VT protobuf still actually outperforms Rust every variation of the Rust ecosystem libraries when it comes to latency and throughput. So I don't expect that to last forever, but I think that's just a testament to how mature the Go ecosystem is for protobuf currently standing. And also when we started, Tonic didn't even exist, so we couldn't have even really done it unless we were going to own building the whole protobuf ecosystem in Rust. So this is the part where I wanted to include the lessons we learned, but make it a little bit spicier. These are the things we learned you're not actually going to need. Like, these are things we actually recommend people don't use in the gRPC ecosystem. The first one is Google APIs. We were pretty jazzed about this at first, but the Google APIs themselves, they're not optimized for allocations. So they do use nested types. So if you are in a performance critical place, you probably actually don't want to use them. They do have... Yeah, well-known types. Yeah, correct. Yeah, yeah, they're also called well-known types. So we recommend that you kind of look at them for inspiration and then kind of use your best judgment with them. The other kind of awkward thing with them is if you're doing generation, sometimes they're already pre-generated in whatever language you're using. And there's kind of this awkward dance where you have to choose to, like, do I generate the code and rewrite the imports so that they look at the existing package as it's packaged in my language, or do I just generate the Google APIs again myself? And after about like the 10th time where I had to explain that to our engineering team, I'm like, okay, this is a little bit too much complexity in the generator. It's kind of annoying. So that's Google APIs. The streaming APIs are what's next. It's not really Yagni. Like, we still use the streaming APIs everywhere. You really do have to use them. But the problem is the code gen is super awkward. Like, it generates really, really bad code. And from the kind of client-facing perspective, the APIs we're going to serve for user experience, we basically end up wrapping them. We handwrite code around them to handle a bunch of the common errors and things that you get out of the streaming APIs, because, like, it's just overcomplicated and we can't expect our end users to really dive deep into gRPC to figure out how they should be like canceling a stream, for example. It's just way too error prone. The next thing are headers and trailers. Headers and trailers, I feel like they're just an awkward UX. You kind of, if you're using these, you're probably trying to sneak data in that should have just been in your protobuf message in the first place. You'll go back later and like, you won't regret just adding that preemptively into your protobuf message. So there is limits to just how long they can be and things like that, and you don't actually have structure. There's a flat byte slice. Next one is buff breaking. This is a linter that actually guarantees that if you make a change to your IDL, you're not going to break the wire format. So that means you can make like kind of forward compatible changes. But the problem I have with this is if you're spending all this time trying to be super clever about what you're trying to break backwards compatibly, you could probably be spending that time actually working on your workflows around actually iterating your API and making it so that you have the engineering muscle to be able to make breaking changes regularly and help customers update to the newer versions so you can just iterate faster in general. We definitely are not like the best at this. We still only are on like V2 or 3 of our protobufs, so we're not great at that, and we do still use buff breaking, but half the time it's kind of flagging us. We're explicitly making a breaking change in an experimental API. The last thing is repos per language. We first start out with a mono repo around the protobuf generation. Then we split things out because we wanted different client libraries for the different consumers. And now we're kind of leaning back towards, okay, maybe we should put them all together because they're all kind of cutting the same version of the API at the same time. And it just makes everything way more simple if you kind of consolidate all that work into one place. Yeah, sure. This is our repos, yeah. Yeah, not gRPC repos. Yeah, these are ours. These are like when you go to generate clients. Yeah. Yep. Yeah, I do. Yeah, the gRPC upstream ones, yes, I like that they're in separate languages. The ones that we're maintaining, I think from my perspective, just the maintenance burden over time, I want them to be centralized. The real reason is when you make a change to your API, you want to immediately see in that PR how it's going to affect like the 10 different languages you support. So like, okay, because you might make a change and you'd be surprised how Java manages certain things versus how Go manages certain things, especially around like packages and organization. So that's kind of the idea behind that. I'm running out of time, so would we do it all over again? Absolutely, yes. Like there still is nothing that competes with gRPC really in terms of maturity and what you get out of it feature-wise. The only things that could possibly make us reconsider would be if our end users, just something blew up in popularity, because once again, we're trying to have the best user experience at the end of the day with the folks integrating with SpiceDB. Better code gen in each language would also do that if someone vastly improved the code generation for a different IDL. And then zero copy, fundamentally, like the more efficient you can get, the better. We have tried and built experiments with Captain Proto and flat buffers over gRPC. Honestly, it wasn't worth the change in the toolchain. So that just is a credit to how mature protobuf and gRPC is in general. So where are we headed? Basically, I kind of alluded to how we're kind of centralizing a bunch of our language-specific repositories for our clients back into one repo. This is so we can generate just specifically protobufs and services from one place. And then we actually want to package those and push them to the different package managers in the different language platforms, so like pip and Python, for example, Maven and Java. And then that way you can build idiomatic libraries on top of that. And the more idiomatic libraries you have, that's where you can put in your custom logic and make that nice. But also the folks that just want to depend on your protobufs, they can just pull the messages in raw and not have to worry about bringing in any other logic that you've built. Then finally, I've actually, the previous talk was talking about how they removed a bunch of memory pooling or memory allocations within gRPC Go itself. That new codec v2 API that they've now exposed, I actually saw that PR get merged last week and immediately this week opened a PR against VT protobuf implementing codec v2 so that we can kind of get the best of both worlds and reuse memory while also using VT protobuf. So I'm super excited for this to land. That is going to probably make the largest performance impact in SpiceDB in, I don't know, 2-3 years. So I'm really, really excited about that feature. So that's it for my talk. If you want to talk to me more afterwards or like dive deeper into any specific topic I covered a lot really fast. Just feel free to talk to me after the talk. Thanks. Do we have time for Q&A or? Yeah, cool. Sure.
So is SpiceDB like a distributor across data centers?
Yeah, so the question was, is SpiceDB distributed across data centers? Yeah, so the original kind of system it's based on is Zanzibar, which uses Google Spanner in the backend. SpiceDB itself actually has various backends that you can plug into. Cloud Spanner is actually one of them. CockroachDB is another one. Postgres is another. So if you have a completely like globally distributed deployment and you need your authorization to be everywhere, you can actually use one of those backends to get that. Yep.
SpiceDB is also a choice.
So SpiceDB will store its data in Cockroach or store its data in Cloud Spanner. Yep. It's kind of similar if you are familiar with kind of how you build other databases. There's like a key value store layer to most databases, and they use like LevelDB or RocksDB. We kind of have that same interface, but we also implement it with other databases. So if you want to get like Raft and geo replication and just like active across a global like deployment, you can do that by plugging in Cockroach. Yeah.
What's the fundamental communication gRPC patterns? Is it unity or bidirectional stream between the client and the server?
Yeah, so the question was, what's basically, what type of RPCs are we using, unary or streaming? And it depends on the API. So we do have like a watch API where you're getting a regular stream of updates and changes to authorization logic. And when you're using that, that's a stream. But most things are unary. Like I said, the UX and the code gen you get out of the unary ones are just better. They're easier for our end users to use. So we try to do unary as much as possible. But the places that make sense, you ultimately do end up streaming.
And a follow-up question,
Mm-hmm.
the consistent load balancer code
Yeah.
that you committed to, is that just doing the load balancer capabilities for unary or bidirectional?
So the question was the consistent hash ring implementation. Does that work with basically both RPC types? It does work with both RPC types. This is just using the built-in gRPC balancer interface. So I'm fairly certain that it will pick, when you open basically the stream, it's going to pick a particular node and not per message going across the stream.
Got it. So if it's bidirectional, then it's going to stick with one.
Yeah, probably.
Towards left.
I'm pretty sure that's the case. Our dispatch API is almost entirely unary. It might entirely be unary. So I'm kind of assuming how the internals of gRPC are working. So, yep.
Of the proto-validate, have you encountered like a need or good patterns for validation across fields, like more complex validations across objects?
So the question was, have we found kind of more complicated use cases for product gen validate? Yeah, I mean, theoretically, every bit of validation that you're going to write in your code base, you wish you could stuff it into product gen validate, just because it's so convenient. The reality is the vast majority of the stuff we care about, we can actually fit into product gen validate, and then it's all kind of the logic, whether or not it makes sense with the end user's schema. So what happens is we get a bunch of data in, and then we look at the schema that they have for the database, and we say, like, is this valid with the context of the schema? And that's basically the only other validation we do per request. Yeah. Yep.
So your talk is mostly about performance.
Mhm.
I'm just curious about how much of a protocol or gRPC is essential for the database itself.
Yeah, so the question was, a lot of this is about performance and how much of the overhead, for example, matters coming from gRPC specifically. Well, the reason why I was saying I was super excited about the memory reusage is because probably something like 90% of our allocations come from gRPC itself. So it is critical. Everything else we've already eliminated because we basically control all that code. So because the gRPC allocations are kind of out of our hands and they're maintained by the gRPC team, it's kind of been like the last bottleneck for throughput for us. So the vast majority of time spent is actually dealing with kind of memory allocations and working with the garbage collection in the language. And almost all of our allocations come from the messages being allocated per request coming in off the wire and all the copies inside of gRPC itself. And the ability for us to basically reuse that memory for the next request that's coming in once we're done, we'll cut those allocations. Probably, I don't even want to give an estimate, but I'm super excited to see the performance gain we get. It will definitely be a huge one in terms of throughput.
So it's mostly the I/O communication between the client and the server that's usually the bottleneck of the whole overall system.
Correct.
Your core system itself, when it's not using gRPC, is actually a very small percentage of actually overall, I guess, profile, whatever you call that.
Correct. Yeah, the footprint of the service outside of that is largely reading from memory because it's such a latency critical service. We keep everything we need to compute most of the requests in memory. That's why we actually dispatch across different instances of gRPC using the consistent hash ring. That's because we're actually sharding up the distributed cache that keeps basically thunks of computations we have to do to process a particular query in memory on each individual node. So we're trying to serve as much as possible from pure memory, and then only when something isn't already in memory do we fetch something from disk.
So do you have a lot of disk communication at all? Or because your backend, it's actually using different backend storage, right? So do you really care about the disk at all, or you only care about networking or I/O to the actually networking side of the backend storage?
Yeah, so the question was, do we care about disk at all, like the disk I/O? We do for write throughput specifically, and making sure that the system stays consistent. So the other thing is if you're working on authorization, if you have a consistency bug in your distributed system, that means someone might get access to a thing they shouldn't have access to. That's a security vulnerability. So it's very, very critical. Yep. So I think that's all the time I have for questions. Thanks.